simplify 1 over x minus 1 plus 1 over x plus 1 all over 1 over x squared minus 1. Just like the last couple of problems, we're going to need to multiply the top and bottom of this complex fraction by the LCD of the smaller fractions. To find the LCD, though, we're going to need to factor that denominator of x squared minus 1. Remember that when we're finding an LCD and our denominators have polynomials in them, we need them all to be factored. The numerator isn't going to change because those denominators are already as simple as they'll get. They are prime, so they can't be broken down or factored. And then in the bottom, x squared minus 1, we know is a difference of squares. It becomes x plus 1 times x minus 1. And now if we're looking for the LCD among all of these smaller fractions, we can see that there are factors of x plus 1 in some of those denominators, but there aren't any multiple factors of x plus 1. X plus 1 doesn't appear in any denominator more than once, so we only need it to appear in the LCD once. And the same is true with x minus 1. X minus 1 appears in a couple of those denominators, but it only appears once within any single denominator, so we only need it to be once in the LCD. And now that we've found our LCD, we need to multiply the top and bottom of the complex fraction by the LCD x plus 1 times x minus 1. It is effectively the same procedure that we've been doing, but it's a bit more of a complicated denominator, so we just have to be a little bit more careful about what cancels. Let's look at the top half of the problem first. We need to take the x plus 1 times x minus 1, and we need to distribute them to both of the smaller fractions. Let's look at the first smaller fraction. Its denominator is x minus 1, but we can see that it's going to get multiplied by an x minus 1, so those x minus 1s are going to end up canceling, and we're left with x plus 1 times 1, which is just x plus 1. So that's going to give us an x plus 1 in the numerator. Then plus, because we have an addition between the two, we look at the second fraction, and we notice that the x plus 1 in the denominator is going to cancel with the x plus 1 on the outside. That leaves us with x minus 1 times 1, which is just going to be x minus 1. So in the numerator, we've got x plus 1 plus x minus 1. In the denominator, the whole denominator of the bottom fraction is going to cancel. We've got an x plus 1 and an x minus 1 in the bottom, and we've got an x plus 1 and an x minus 1 on the outside. All of those cancel, and we're just left with 1. Now we can combine like terms in the numerator. X plus x gives us 2x. And 1 plus negative 1 is 0. Those terms cancel out. And so we're just left with 2x in the numerator and 1 in the denominator. And 2x divided by 1 is just 2x. So this whole complicated rational expression with fractions inside of fractions and binomials in the denominators, when we go through and do all of the simplification, in the end, this simplifies to just 2x, and this is a really good reason why we simplify expressions. It's always easier to deal with 2x than it is to deal with 1 over x minus 1 plus 1 over x plus 1 all over 1 over x squared minus 1.